The last category of compounds that remains to be named is acids. We have not seen acids before, so this session will serve as a very short introduction to an acid before we get into naming these compounds. Something that is very important for you to remember is that acids are molecular compounds. They are never ionic. They do not have ions. They have molecules as their smallest independent units, and they are molecular compounds. There are no charges in these molecules. The other thing that also we will at least be consistent with, just because this is new to us, is how do you recognize an acid? How do you distinguish between an acid molecular compound and a non-acid molecular compound? An acidic molecular compound, at least in our class, will always have an H as the first listed element in the chemical formula. For example, if we write a chemical formula such as, is this an acid? No, this is a molecular compound. This is a molecular compound, but not an acid. However, if we write this is considered to be an acid because, again, for the purpose of our class, this will change later on. How about is also an acid because it has the H as the first listed element. So we will follow those trends, those guidelines when we represent acids. Now, acids are molecular compounds. They are not ionic. They do not have ions in them, but they are very special molecular compounds because they ionize when they are dissolved in water. Whenever acids are dissolved in water, they ionize. What does that mean, ionize? Ionization is a chemical process where a molecule breaks up into ions. Now, please notice my words. A molecule breaks up to create ions. In other words, let's say if we had a molecule such as and I'm just saying XY. There's a covalent bond between X and Y. And remember that there are two electrons in that covalent bond. Now, if this bond breaks such that both the electrons in the covalent bond go to Y, then Y becomes an anion, and X, because it lost those electrons, essentially becomes a cation. So this process is called ionization. It is a chemical process because you're creating ions that did not exist before. So acids do that. When you dissolve an acid the molecule will break up to create ions in such a way. Now this is how we represent an acid, HA. H is the hydrogen that is the acidic hydrogen, and when it dissolves in water, it breaks the molecule HA, breaks up such that the hydrogen atom or atoms that are acidic that were written in the front of the chemical formula, all of those become an H plus ion. Each H ion will have one positive charge, and the rest of the molecule becomes the anion. As always, since you started with a neutral molecule, you must have ions such that the charges balance out. That always has to be the case. So just to show you a few examples, HCl is an acid. When it dissolves in water, once again, when it dissolves in water, it does so such that the molecule breaks up right there to create an H plus ion and chloride ion. H2CO3 is also an acid. It breaks up right there again. Now this time the molecule had two hydrogens, therefore two H plus ions are created per molecule of the acid, and the rest of the molecule becomes an anion. If you recognize CO3 2 minus is carbonate from your polyatomic table. H3PO3 initially has three hydrogens in the molecule, so it will create three H plus ions, and the rest of the molecule again is the anion, phosphite, again from the polyatomic table. Now please notice that since you're starting with a neutral molecule, after ionization, the total number of plus and minus charges must be equal, and that should always be the case. Okay, so whenever acid molecules ionize, they will make H plus ions and an anion. Just note the H plus ions are commonly known as protons. So the whole idea of that these compounds are acidic is because they can make protons, in other words H plus ions, in aqueous solutions when dissolved in solutions. Actually, if you really think about it, when you really learn about acids, you will realize that it is the H plus ions that make these acids. This is what makes a compound an acid. If a compound were not able to produce protons or H plus ions, in other words, in an aqueous solutions, those compounds will not be acidic. Okay, one more highlight here that I really want to emphasize on, just because it is so important, is that for you to remember that ionization is a chemical process. When a neutral molecule, is breaking up to create ions that didn't exist before, it's a chemical process. But when an ionic compound that already had ions dissociates in water to make ions, that's not a chemical process. That's a simple dissociation of ions. That's a physical process. Okay, so let's try and use this knowledge to write the ions that the following acids will make when dissolved in water. Okay, go ahead, give it a try yourself. Pause the recording for a minute or two while you complete this. Okay, so the first one, when this is dissolved in water, once again the molecule breaks up such that H plus is created. How many H pluses for this one? 2, because there were 2 to start with, and then the rest of the molecule becomes the anion. What do you think will be the charge on the CrO4 ion? Of course, it is a polyatomic ion, so you probably have memorized it. If you are not sure, you can't remember what is the total positive charge. There are 2 positive charges from the protons, so what should be the total negative charge in order to balance it out? Exactly, 2 negative. For the next one, once again, each molecule of HBr will only make 1 proton and 1 bromide, and the third one, will also make 1 proton because there was only 1 hydrogen in the molecule, and 1 nitrite. It is very important for you to memorize and remember the names of polyatomic anions, especially now, because that knowledge is very important to name acids. Something else that I must mention, because I haven't done this yet, the way we are writing this, for example, this process, this is called a chemical equation, and we will write many of these later on towards chapter 10. But FYI, because when I do, you should understand, it's a chemical equation. It tells us substances that we started with, substances that we ended with after a chemical process. The arrow gives us the direction of the process, of the chemical process, and the plus sign only indicates and. It only says and. So when HNO2 dissolved in water produces H plus and NO2 minus, proton and nitrite. Okay, let's work backwards. If you know the anion a certain acid would produce, can you write the chemical formula of that acid? That's a very important skill to have, again, for naming purposes. So let's give that a try. if a certain acid was going to produce C2H3O2 minus. Now, what anion is it? What's its name? Yes, it is an acetate anion. Once again, the knowledge of this is extremely important. Please, if you have not memorized your polyatomic ions yet, this is the time when you must have them down. Okay, so if an acid is going to make an acetate ion, then how many H pluses does it need to balance out that negative charge? 1. Exactly. So if that's the case, what is the chemical formula of this acid? HC2H3O2. Now, once again, to remind you, this makes the proton and this makes the anion. And if you remember that the charges must balance out, this you can figure out therefore the formula of the acid itself. You might want to pause the recording for a minute or two while you write the chemical formulas for the remaining. Phosphate will be produced from H3PO4, and this is going to be produced from HClO2.